Welcome to our channel Euclid Mathematics. We have started lecture series on CSIR NET SET Gate and other competitive exam. Within that, I already uploaded plenty of the videos on my channel. So if you wanted to see this video, you may check it into my playlist. So in my today's video, I'm gonna explain to you all one of the question from Gate Mathematics, which is completely based on the linear algebra. Okay, Gate exam is coming, so we need to know previous year question from Gate exam. So guys, I'm here with the previous year solution. So if you found this helpful video, so if you have any doubt, let me know in comment section. Okay, so here in my first question, and one thing to you all guys, so it is not easy to upload one single video on YouTube. There behind of it, it's really hard efforts, because to record video, to make it edit it and to upload everything is really difficult. But for you all guys, I'm trying to do my best and trying to upload plenty of the videos for you all. Okay, so if you like the videos, please let me know in comment section. I'll feel more better, and that motivation makes me upload more and more videos. So now let's get started our today's question. First of all, I'm going to explain to you all question, and then we'll go for the detailed understanding of solution. So here in our question, we have given M is an invertible Hermitian matrix. Okay, and let xy belongs to R be such that x square condition given here on x and y, x square strictly less 4y, then we want the which one of the option is correct. Okay, so question it is from the Gate exam 2 marks question. First option say that both m square plus xm plus yi and m square minus xm plus yi are non-singular. That means these two characteristic equation non-singular. Second option says that these two characteristic equation are singular. That means if A true, then B wrong, or B true, then A wrong. Okay, it is like this. Now next, first characteristic equation is singular, but not is non. Second is not non-singular, not singular. That means non-singular. Fourth option it says that if first option is a non-singular and second option is a singular, so we have to find out the characteristic equation. That means we have to find out their matrix by using our given condition. Okay, so this one is the question, so we have to figure it out which one of the option is correct from within this 4 option. Okay, so question it is very easy, just need to apply some basic concept. Now let's get started on today's solution. We'll go for detailed understanding of each and every option. We'll understand what we have given in our question. So in our question, we have given M is an invertible matrix. So what is meant by invertible matrix? The matrix which determinant is non-zero. The matrix which determinant non-zero, then we say that it is invertible matrix. Okay. So the matrix which is determinant non-zero, so it is an invertible, M is invertible matrix given. Okay. And one more condition, the matrix need to be Hermitian matrix. Now, what is meant by Hermitian matrix? Hermitian matrix, Q-Hermitian matrix, symmetric, Q-symmetric matrix. These are the quite confusing for matrix. Okay, but very easy to remember. Okay, if you take the symmetric matrix, that means you have to take symmetric A transpose which is equal to A, then symmetric, Q-symmetric, then you have to take A transpose which is equal to minus A. Okay, skew symmetric. And symmetric, skew symmetric, it defines for real number. That's why we taken A and their transpose. Okay, it is for the real. But when we got the complex type of the numbers, then we use Hermitian and skew Hermitian. So Hermitian matrix can be represented as A which is equal to A tranjugate, and skew Hermitian can be represented as A which is equal to minus of A tranjugate. Okay, so this condition very much important here to understand. So we have to deal with the Hermitian matrix. That means Hermitian means A which is equal to A tranjugate. Okay, A which is equal to A tranjugate. A tranjugate means conjugate of a transpose. We have to take conjugate, then we have to take transpose. Then this is the A tranjugate. Okay, the meaning for tranjugate is a conjugate and then transpose. Okay, but in a skew symmetric matrix, we need only the transpose. But in a Hermitian matrix, we need a conjugate and then transpose. Remember it. Okay. Now A is invertible matrix. It is also Hermitian matrix, and xy from real number. Okay, xy two element which is belongs to real number. Okay, and one more condition is given: x square smaller than 4y. Okay, x square is smaller than 4y. So you all need to remember these conditions. Okay, this condition is very much important to solve our question. Okay, I hope you all have understood these conditions. Now let's apply this condition. Try to make some counter example that can omit our options. Okay. So we cannot make option correct by using option counter exam, but we try to discard the options. Okay. Now here, so first of all, try to create the matrix M. Okay, we need a matrix. Okay, matrix M we need over here. So mostly try to create 3 by 3 matrix. Okay, 2 by 2 it is okay, but not always hold for all characteristic equations. So characteristic equation in the form of a 3 2 here. So try to create 3 by 3 matrix here. That can be easier to find out our options. Okay, now we want the first matrix where determinant non-zero. That is the first condition. Whenever we take A transpose of a conjugate, A is equal to A conjugate, we will get that matrix here. That second condition need to hold, first need to hold. Okay. So by using these two conditions, make one matrix. So it is easier that to create a 1, 2, 3 as a diagonal matrix. Okay. Very easy to create such a counter example. Okay. If you are going to take A which is equal to A transpose, so conjugate of a real number always that real number itself. Okay. Whenever iota term is coming, then it is a conjugate, it goes to negative iota. Okay, so it affect on only iota, but I consider 1, 2, 3 as a matrix from complex. Okay, so this may be as a real number is a subset of a complex. So I can write that 1, 2, 3 is a subset of complex matrix. Okay, so and we can see that it is a diagonal matrix. That means determinant is a multiplication of diagonal. So determinant of M which is also non-zero. Okay, so here we can see determinant of M is non-zero. So the A which is equal to A conjugate, that means this matrix is a Hermitian matrix. So Hermitian matrix conjugate is also A is equal to A conjugate is given, and matrix is invertible. So I made here one counter example. So you may try to make some other counter example. Okay, don't copy me. You have to create your own counter example as your mind says to you. Okay, so I got this matrix M. Now apply this matrix to our first characteristic equation and find out its values. So first characteristic equation is given M square plus xm plus yi. Okay, this is the characteristic equation is given first. So we have to check whether it is singular or not singular. Now M is there, then M square, how can we write? It is a diagonal matrix, so M square become only the square of a diagonal. So 1 square is 1, 2 square is 4, 3 square is 9, remaining term 0. Okay, so M square, put it here, 1, 4, 9 is a diagonal element. Okay, remaining elements are 0, plus x into M. Okay, x into M, the value for M is 1, 2, 3, remaining element 0, plus y into identity matrix. If you consider here 3 by 3 matrix, so take identity also 3 by 3 matrix. Okay, remaining element 0, which is equal to 0. Okay, now find out the value for matrix. Okay, add their matrix, add this matrix. 3 different matrices are these, and create one matrix and find out whether it is a determinant 0 or not. Okay, now add the corresponding element 1 plus x plus y. Okay, 1 plus x plus y. I hope you all can add two matrix. Okay, this is the addition for corresponding element between the two matrix. Okay, it is nothing difficult here. So if you don't know this, you may check my playlist. 1 plus x plus y, here first element. So remaining element all goes to 0 because 0 0 is there. 0 plus 0 plus 0, 0 plus 0. In x multiply y multiply, it becomes 0. So all element go getting 0. Now 4 plus 2x plus y. So 4 plus 2x plus y and 0. Okay, last term getting 0, 0, again here 0, again here 0. So 9 plus 3x plus 1, 9 plus 3x plus 1. Okay, so I got this 3 by 3 matrix over here. Okay, I got the 3 by 3 matrix, 1 plus x plus y, 4 plus 2x plus y, and 9 plus 3x plus y as a diagonal element. Now determinant of this 3 by 3 matrix means multiplication of a diagonal. Okay, diagonal matrix means determinant means multiplication of a diagonal. So write it 1 plus x plus y multiplied by 4 plus 2x plus y and multiplied by this 9 plus 3x plus 1, 9 plus 3x plus 1, which is equal to 0. This is a determinant of matrix. Okay, that means multiplication of a diagonal element is a determinant of a matrix. Okay, so 1 plus x plus y, this is the multiplication of a diagonal element. Okay, now we want the determinant, means we want the value for this one. What we will get the value? It is a 0 or non-zero. If it coming 0, then it is singular matrix. If the value coming non-zero, it is non-singular matrix. Okay, that means invertible, non-invertible matrix. We'll get it here. Okay, now we have to select x and y such that this given condition hold. X y belongs to R and x square strictly less for y. Okay, so x y belongs to R. Any element you may select, but condition need to hold that x square strictly less for y. Okay, select such a element that can hold this one. Okay, now it's my suggestion to you all over here. Whenever we select x and y here, so always we need to remember the value for x and the value for y, always select smaller. That can helpful to find out the calculations. Okay, because whenever you take the bigger value, answer will remain same. Smaller value, answer will remain same. That value need to satisfy this property only, but bigger value takes more time and more space to solve this one. Okay, so we don't have time and space in exam, so we have to select the smallest value. Now if I consider x is a 1 and y is a 1 from the real number, can it property satisfy? 1 square is a 1, 4 into 1 4, so this one is satisfied. Surely 1 is strictly less 4. Okay, this one is satisfied here. So x is 1, y is 1 possible. Put x1 y1 over here, find out determinant. 1 plus 1 plus 1 3 multiplied by 4 plus 2 plus 1 4 plus 3 7 multiplied by 9 plus 3 9 3 plus 1. Okay, 13. Okay, which is equal to 0. Can we say that this one is a 0? Is it this one 0? So we have to discard the option. We cannot make the option correct, we can discard the option. Okay, so 3 multiplied by 7 multiplied by 13, this is non-zero. Okay, if this is a non-zero, that means determinant of our first characteristic equation is a determinant. This determinant is a non-zero. If determinant is non-zero, that means this characteristic equation is having singular value. Okay, now here in our option, say first says that both non-singular. Okay, so first is a non-singular. Now we have to check whether second is non-singular or not. Okay, first is a matrix, first characteristic equation is non-singular, so we have to check second one whether it is non-singular or not. So you have to repeat similar process for second one. Instead of plus, we have minus here only. Okay, remaining all the process remains same. So here I solved this part over here. You may select check my answer for your detailed understanding. Okay, so this is the solution. These are the diagonal elements. So I found their determinant using our given condition. I consider x1 y1. So why I consider x1 y1, I explained already in my earlier part. Okay, so determinant is coming as the multiplication for this, which is a non-zero. So that means first characteristic equation is non-singular. Now second characteristic equation we have to replace negative over here. Okay, so if it is negative here, then that means in negative x it is coming. Keep all the values for matrix remain same. Okay, you get this matrix and solve this matrix further. As you all can see, I got the determinant over here, x1 y1. Again I selected this. Okay, so put this value x and 1 y1 in our equation. We will get the determinant as non-zero. Okay, again second characteristic equation gives us a determinant non-zero. Okay, this is some type of polynomials are there. Okay, these are the determinant having non-zero, so both are the non-singular. Okay, if both are non-singular, so in our option number first it says that both are non-singular, so first option true. Second option it says that both are singular, it is wrong, so we can omit that option. It says that it is first characteristic is a singular, it is omitted, and second is singular, it is omitted. So 3 omitted, so obviously first is true. We cannot make option true directly, we can omit the option. So 3 omitted, that means obviously first option is coming true. Okay, so that's it for my today's lecture. I hope you all have understood everything here in my today's lecture. Nothing is difficult over here. We just have to find out the determinant of our matrix. Okay, the Hermitian matrix, we have to find the determinant for it. So I hope you all have understood everything. If you found anything difficult, let me know in comment section. I will come up with some other videos. So thank you everyone. Thank you for my today's lecture.